Section 2.2, number 37, we're asked to find the limit as x approaches 1 from the left of inverse tangent of x divided by inverse cosine of x. And I've got to go back and check my directions here, and it tells us that we're actually estimating the limit numerically or state that it doesn't exist. So when they talk about using a numerical method to estimate a limit, we're talking about making a table right here. So we're going to go with an x and an f of x column in our table. And the one thing that's nice about this problem is they're just asking us to do a one-sided limit. The limit as x approaches 1 from the left. So I don't have to worry about any x values that are greater than 1. Now what I'd really like to do, of course I want to make this as easy as possible, I might start with something like tenths. I might start, let's say, maybe with something like 0.7, and then just increase that number by 1/10 each time, 0.8, 0.9, and my hope would be then, I think this will be pretty quick and easy to put in the calculator, that we'll be able to tell from this table what y value we are converging towards, and therefore be able to come up with an estimate for our answer here. But let's see, we don't really know that until we get to the table itself. So, how are we going to handle that? I'm going to do that on my iPad right here, and it should work pretty much the same it does for you guys. I am going to go to, let's see if I hit that button right here. Okay, I'm going to go to my main calculator page, and then we're going to define this function here, everybody. So this is going to be menu 1 and 1. We're going to define this function right here as, and I just had it. You can call it whatever you want. So I'm going to go with, oh, where's my F hiding? No, not there. Is it here? It is under that. There we go. So we'll call this F, I'll go with F1 of X. Gotcha. And I want that to equal, that's where that is. All right, and we've got a stacked fraction right here, and we've got inverse tangent of x in the numerator. So I'm going to go to my trig menu, and okay, inverse tangent of x. And all of that is going to get divided by the inverse cosine of x. You do want to make sure you're in radians here, everybody. That's the way we want to spend most of our time, and I can see in my left-hand corner here that I am. So I'll go ahead and hit enter, and it tells me that that's done, and we are good to go. And so, trying to do this the way I've set you guys up, I could do this from the calculator screen right here, but what fun would that be? I'm going to add a page and do a list and spreadsheet. And I'm going to type here in cell A1 what I want that initial value to be, which is going to be 0.7, and there you go. Now, right underneath that, I want to get the spreadsheet to do the work for me here, guys. So I'm going to let cell A2 here equal, meaning I want it to do some math for me, cell A1, but then we're going to add 0.1 to that. And when I hit enter, there's the 0.8 that I was looking for. I'm going to copy that cell right there. You guys are going to hit Control-C, and then I'm just going to fill that down. Actually, it doesn't need to go down very far. And now I'm going to paste that, and yes, that's fine. Okay, and there's my 0.7, 0.8, and 0.9. Then, in column B, I'm going to go to this cell that's directly above B1 here, and this is where we can say that we want this thing to do some math. So an just one equals right there. And we want to take that function we wrote just a second ago, which was F1, and we want to evaluate that at whatever your A column is. Now, I'm a little worried because F was bold there a second ago, and then it went italics. And now that makes me think maybe I've goofed something up here. Did I just call it F? Let me go back to where we were. No, it was there, F1 of X. That was odd. Okay, so let's see if we can get this to work then, guys. So where was I? Right here. There you go. So again, above B1, we're going to say, okay, the equals is there already, and we want this thing to evaluate F1 of the A column. So let's hit enter there. All right, and this is what we've come up with here. And yeah, I was a little bit worried about this, guys. If you look at those three y values that we just came up with in column B here, they're not really clearly converging towards anything. I got a 0.767, a 1.048, and a 1.625. I don't really know that that's conclusive, so I'm going to try to change my tactic here just a little bit. Maybe instead of going hundredths, what I probably should have done, because that one's a little vague right here, maybe let's try, instead of tenths, I'm sorry, I think I said that wrong, let's try hundredths. What if we started at 0.97 and then we added 1/100th to that each time, and ended up at 0.99. Now, how would I fix that in my spreadsheet here? So instead of 0.7, let's just delete that and start it at 0.97. Hit enter right there. Syntax error in column B. That's interesting. I didn't think that was going to happen, but let's keep going right here. And then let's change that formula. Instead of adding a tenth, now we're going to add 100th, and we would get that one there. And if I just copied this cell and pasted it here and hit OK, okay, what do we see now here, guys? This isn't a whole lot better. My y values still don't really clearly seem to be converging towards anything. We're going from 3.13 to 3.87 to 5.51. All right, here's another idea. Instead of hundredths, let's try thousandths. Instead of 0.97, let's try 0.997. Okay, and then, yeah, I know what the problem is here. Instead of adding a tenth or a hundredth, we'll add a thousandth. Yep, okay, and then we'll copy that and do the same thing right here and hit paste and go OK. And now I'm starting to see the same thing over and over again. My y values are increasing, but they're not really getting closer towards anything. So even if I were to show my work right here and say, wait a minute, I decided to cram another 9 in each one of those cases right here. That's real classy. All right, I still don't like these numbers that I have. 10.118. Let me write that one down just to kind of show my work. Okay, and then I've got 12.400, 17.549. Okay, well, I forgot what it was. Anyway, the point there is, guys, we are not seeing the clear convergence here that we want, but what we are seeing is that those y values seem to be increasing kind of without bound as we go down on this table. So I think the best thing I could say is that my answer to this question is that my y values seem to be increasing without bound, which means that we would say that our limit there is infinite. So yeah, that's a kind of a goofy problem right there. We'd like to see convergence towards a clear finite number here in the y table, but sometimes it increases without bound, and that would be what's happening here in problem number 37.